This talk is for engineers building local AI tools, not for video editors shopping for a new timeline. The question is simple: if your stack already runs locally and produces structured artifacts, should your videos still be made by hand with a screen recorder and a non-linear editor? My answer is usually no. Remotion gives you a programmable presentation layer on top of those artifacts. That means explainers, previews, demos, and recap videos can be generated from the same local state that your product already understands. The hard part is not getting pixels onto a video track. The hard part is making the explanation match what the system actually did. Local AI products already have the ingredients, saved prompts, tool calls, command output, screenshots, code diffs, and transcripts, but many teams throw that structure away and record a one-off walkthrough by hand. The result looks fine once, then drifts. Remotion matters because it lets you preserve the structured truth of a run and turn it into motion without giving up determinism. Remotion is not a desktop editor with a scripting hook bolted on. It is a React-based video framework. You define compositions, pass props, and render output from code. That framing matters for local AI work because code is already where your truth lives. If your application state is in JSON, TypeScript, Python, Markdown, or a database record, you can map it into a composition directly instead of manually recreating it in a visual timeline. That reduces translation loss between product state and the story you want to tell. Screen recording is a camera pointed at a workflow. Remotion is a model of the workflow. That difference is huge. If a line of code changes, if a caption needs correction, if the narration timing changes, or if the same explanation needs a different brand treatment, the Remotion path rebuilds from source. In local AI development, that is especially useful. A lot of the content is already machine generated and variable. You want a system that can ingest new runs, not a process that asks a human to re-record every small change. One reason Remotion is approachable is that the core timing model is small. You ask for the current frame, map it into values, and compose scenes with sequences. That is enough to build most explainers. For local AI content, this is ideal because the narration usually wants staged reveals. First, show the request, then show the planner decision, then show the tool result, then show the diff. You do not need a giant animation system to do that. You need a clear timing model that keeps the story synchronized with the data. This is one of the most practical Remotion features for AI pipelines. The metadata hook lets the composition set duration, size, frame settings, and input data before the render starts. Your video length does not need a fixed number in source. If an agent run has 10 steps one day and more the next, the composition can size itself from real input. That is the exact shape of a local AI problem. The data changes, but you still want deterministic output. Officially, Studio is the local preview surface. It lets you inspect compositions, scrub frames, and iterate on the scene system while your code stays live. For local AI development, that matters because the authoring loop is already local. You're often testing model prompts, UI traces, or generated assets on the same machine. Studio keeps video iteration in that loop. You do not need to hand off to another department or another toolchain just to see whether an explanation of a run feels legible and correctly paced. The player is where Remotion stops being only a renderer and starts becoming product infrastructure. The official docs describe it as a way to embed Remotion videos in a React app and customize them at runtime for local AI tools that is useful for review. A user can inspect a generated recap before export. An engineer can preview a tutorial assembled from stored logs. In practice, video becomes a live view over application state, not just a final export. Real AI products rarely have every asset ready in line. You may need transcripts, screenshots, stored traces, or generated media. Remotion handles that with an explicit wait. One call delays the render. Another call resumes it when the inputs arrive. The key point is not the API name. The key point is that the dependency is visible. You declare that the render is blocked until the data is ready. Is the same discipline good local AI systems need everywhere else? If the source material is structured, keep it structured for as long as possible. A saved run like this is already better than a screen recording. It exposes intent, action, and result separately. Remotion can then decide how to reveal it. Maybe the tool name lands first, then the summary, then the associated code diff, then the final result. That approach is cleaner for tutorials, postmortems, and user-facing recaps. It also means the same run data can drive HTML previews, transcripts, and rendered video without inventing 3 separate representations. This layered design is the right mental model. Do not make Remotion own everything. Keep narration, captions, media generation, and trace normalization in their own stages. Then let Remotion handle presentation and export. Each layer should have one job. If voice timing is wrong, inspect the narration step. If pacing is wrong, inspect the scene data. If artifacts are wrong, inspect the normalized run. Local AI products get messy fast, so clear boundaries matter. One thing local AI teams constantly need is explainability. Not just outputs, but architecture. What called what? Which tool actually changed the file? Which step was model selected and which step was deterministic? Remotion is good at this because architecture diagrams, subtitles, and code panels can all live in the same frame and reveal progressively. That is much more teachable than cutting between static slides and a terminal recording. The viewer sees the system boundary and the concrete artifact at the same time. This is where Remotion feels especially strong for software education. Most engineering explanations are guided code reviews. You focus a handful of lines, explain why they matter, and then move on. A good renderer highlights one code group at a time instead of dumping the whole file on screen. That pattern fits local AI work because agent runs patches, and workflow definitions are easier to understand as staged review artifacts than as a fast terminal session. Remotion has official documentation for caption workflows, and that matters because AI explainers are often dense. If a viewer misses one technical term, the whole section can collapse. And in a local-first pipeline, captions are also valuable artifacts in their own right. You can diff them, index them, search them, and regenerate them. The broader point is that narration, subtitle timing, and scene timing should not be managed in separate worlds. When they come from one pipeline, the result is easier to maintain and easier to trust. This is the clean comparison with the other projects in this repo. Comfy UI is an engine for generation. NeoVim is a runtime for editing and structured interaction. Bruno is a local API workflow surface. None of those are primarily presentation layers. Remotion that is why it complements them instead of competing with them. The more structured your local stack becomes, the more valuable a programmable output layer becomes. You can explain and distribute the system without flattening everything into raw screenshots or hand-edited captures. A good Remotion pipeline for AI content should have a boring repo layout, authoring sources in one place, generated build artifacts in another, shared scene code in a stable app directory that keeps review simple and automation easy. If everything is implicit hidden in a GUI project file or scattered across temp folders, the workflow stops feeling like software engineering and starts feeling like media ops. The whole point of using Remotion here is to keep video generation inside normal engineering habits: source control, code review, repeatable builds, and explicit outputs. If you're making explainers for serious software, quality comes more from checks than from flashy motion. You want dependency probes, build logs, subtitle output, timing previews, and deterministic rebuilds. That is one reason I like the Decksmith plus Remotion arrangement. It treats video as a pipeline with stages you can inspect. In local AI work, that mindset is mandatory. Models change, runtimes break, and generated assets drift. Strong checks keep the explanation honest and keep the final export from becoming a mysterious black box. This boundary is important. Remotion is not your agent framework, workflow engine, or safety system. If the run data is vague or wrong, the video will present that bad information clearly. The fix is upstream. Remotion should receive strong artifacts from the rest of the stack and turn them into preview and export surfaces. It should not be asked to solve planning, retrieval, or execution problems on its own. Clear boundaries make the system easier to evolve. The strongest first project is narrower than most teams expect. Do not begin with a general video editor for every possible AI workflow. Start with one recurring thing your team already needs. Maybe a 90-second recap of a coding agent run, maybe a narrated explainer of a comfy UI workflow, maybe a changelog video for an internal tool. Save the structured artifacts, map them into props, and build that vertical slice well. If that works, expanding into richer previews, template systems, or end-user video apps becomes much less speculative. The core message is this: Remotion is valuable in local AI development because it turns structured software artifacts into structured media artifacts. That sounds obvious, but most teams still bridge that gap manually. If you're already serious about local runs, inspectable outputs, captions, and deterministic builds, then video should live in the same philosophy. That is where Remotion helps most. It lets the final presentation stay programmable, reviewable, and rebuildable instead of becoming the one part of the stack that falls back to manual craft alone.